Welcome back to Unit 2 this time. So Unit 2 is all about electrons. So that's the focus of this unit. The first page of the packet has the next set of elements, the names and symbols that you want to work on learning. And then the bottom part of this first page has the fireworks model. So this is something that you will do separately, looking at a video of fireworks and kind of thinking about what you are currently thinking about how firework colors come to be. By the end of the unit, the goal is that you can explain this at the atomic level. So what's happening inside of atoms that produces those different colors that we see when fireworks go off. Let's go ahead and flip over to page number 2. So on page number 2, we're going to be looking at the quantum model of the atom, which really kind of starts with Bohr. So last unit, we talked about some of the other scientists like Rutherford, Dalton, Chadwick. So this unit, we're going to focus a little bit more on Bohr. So Bohr studied specific frequencies of light given off by atoms when they were burned. He figured out that electrons were moving between different energy levels, and what he figured out is if the electrons started here, for example, and then they were burned, what was going to happen was these electrons were actually going to jump farther away from the nucleus when energy was put in. So if you picture a rubber band, I have one here, this is where the electron might be right now, but if it was burned, then it gets energy and that makes it stretch and move farther away from the nucleus. Once it's stretched and farther away from the nucleus, its natural instinct, so to speak, is to relax back to its original state. So when burning, it stretches and then it releases, and when it goes back, it releases colors of light that we see in fireworks, for example. Okay. So what he did, he figured out that electrons moved from these energy levels that are close to the nucleus. These are called lower energy levels, which are also given the name of ground energy levels. And then they move to higher energy levels. And higher energy levels are called excited. Okay, so if you're excited, you've gotten a bunch of energy. Okay. He realized that energy seen as different colors of light are then emitted. Okay. Energy seen as different colors of light, the sentence isn't finished, are emitted when electrons fall back down. Okay. So again, this process of moving the electron away from the nucleus, energy goes in when that electron is moving away from the nucleus, and then when the electron returns back to its original spot again, then that energy is released. Okay. Bohr, this is kind of the information that he used in order to figure out that electrons are arranged into different energy levels, which we show as rings around the nucleus. And we give this a symbol. We call this N, which stands for the energy level. And this is called a quantum number because we actually number them. So if these electrons are in the first ring away from the nucleus, this is energy level 1, N equals 1. This is energy level 2, N equals 2. This would be N equals 3, and it would continue on. Okay. What that energy level tells us is the average distance from the nucleus that those electrons are located, and it gives us an idea of the size of the electron system. If an element only has one energy level, it's going to be pretty small. If an atom has 7 energy levels, 1, 2, 3, 4, 5, 6, 7, it's going to be a lot bigger. Okay. The way that I know how many energy levels an element is going to have, it's actually pretty simple. We just look at the periodic table and we look at which row of the periodic table the element is in, and that tells us how many energy levels it's going to have. For example, hydrogen is in row 1. It's only going to have 1 energy level, 1 ring of electrons around the nucleus. Lithium is in row number 2. It would have 2 rings of electrons around the nucleus. Something like francium is going to have 7 rings of electrons around the nucleus. All right, with that being said, if we're going to draw the Bohr model, the first thing we're going to do is just draw the nucleus. That's always the center of the atom, so we start with that. And then off to the side, we would write the number of protons and the number of neutrons that are located in the nucleus. We learned how to do that last unit. So I'm just going to go ahead for each of these. Here's my nucleus, just a dot in the center. And then I'm just going to write down somewhere over here how many protons and how many neutrons. I'll do that at the bottom for these ones. So remember that the number of protons comes from looking at the periodic table, and we just look at the atomic number. So for hydrogen, the atomic number is 1, so that's the number of protons. And then the number of neutrons is what number do I have to add to 1 to get to the mass. So the mass here is 1. I already have 1 proton, so the number I need to add to 1 to get to 1 is 0 for the hydrogen atom. Next up is lithium. So protons for lithium on the top here would be 3. And then the number of neutrons is looking at what number I'd have to add with 3 to get to 6.941. 6.941 is about 7. So 3 plus 4 would get us to 7. Last one is neon. So for neon, I have 10 for the number of protons. And then I'm looking for what number I would add to 10 to get to about 20. And that would be 10 plus 10 is 20. Okay, so that's our first step for our Bohr model. The next step says draw the first energy level. I'm actually going to kind of figure out step 2 and step 4 at the same time. How many energy levels do I need? So I'm just going to kind of figure out how many energy levels do I need by looking at which row of the periodic table the element is in. So hydrogen is the very first element. It's in row number 1, so it's going to have 1 energy level or 1 ring. Lithium is right below it. It's an energy level or row number 2, so lithium is going to have 2 rings of electrons around it. And neon is actually in the same row as lithium. It's just all the way at the end, but it's still in row number 2. So neon is also going to have 2 energy levels. So for hydrogen, I'm just going to draw 1 ring. For lithium and for neon, I'm going to draw 2. Okay. So from there, in order to figure out how many electrons go into each of the rings, and I'm going to draw electrons, you can draw them either as just little dots, like we're drawn up here, or you can draw them as like little negative signs, so whichever you prefer. In order to figure out how many electrons we're going to draw, we're going to count from left to right across each row, and that's going to tell us how many electrons go in that ring. So for hydrogen, hydrogen has 1 ring, and how many electrons go in it, I'm just going to count hydrogen is the first box. So it's going to have 1 electron in that first ring. And at that point, I've reached the box for hydrogen, so my Bohr model is done. I've ended the story because I got to the element that I wanted to get to. For our next one for lithium, in order to get to lithium, I have to read the periodic table like a book. I have to start at the top and read left to right, and then top to bottom. So in order to get to element 3, I essentially have to read element 1, 2, and then 3. So when I'm reading across the periodic table, in row number 1, there is 1, 2 boxes. That tells me that for lithium, in the first ring, there are 2 electrons. And then I go down to the next row. So now I'm in row 2. These are the electrons that go in ring number 2. And lithium is the first box. So in this second ring, the second row, lithium was the first box, which means I just put 1 electron. Okay, so lithium has 3 electrons total, 2 in the first ring, 1 in the second ring. For neon, in the first row of the periodic table, I count across 1, 2. So neon's first row had 2 electrons, so its first ring has 2 electrons. And then I go down to the second row, and I'm going to count across until I get to neon. 1, 2, 3, 4, 5, 6, 7, 8 to get to neon. So in the second row, I need 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And I just kind of spaced them out. Okay. So looking at the periodic table tells me how to draw the Bohr model, just based on which row it's in is the number of rings, and then how many boxes there are in that row is going to tell me how many electrons to draw for the picture. And I didn't fill this in. So the number of squares is the number of electrons that we draw in our picture. Okay. All right, last little bit. In the Bohr model, an electron is going to jump to a higher energy level. So an electron that absorbs energy. So if we take an element and we put it in fire or we blow it up with a firework, if it absorbs energy, that lets it jump to a higher energy level. This higher energy level, like I said before, is called the excited state. When an electron enters the excited state, it will not stay there for very long because it's attracted to the nucleus. Electrons are negative. They want to be near the positive nucleus. So at that point, it's going to return back to the ground state, which means where it started, closer to the nucleus. And during this process, it's going to lose energy. And when I say lose energy, that really just means release energy, and that's the energy that we see as light. When a sample of an element is heated in a flame, it produces a unique color. When viewed through a prism, the flame color can be broken down into a spectrum. So there are multiple colors of light: red, orange, yellow, green, blue, purple. And we might see one color with our eyes like red, but there really might be a little bit of yellow in there too. And so if we use special tools like spectroscopes or diffraction glasses, we can actually see some of those other colors that are present, even though red might be the dominant color that we see with our eyes. There might be underlying colors there as well. Okay. Different elements generate different line spectra based on the number and types of electron transitions that occur when the atom gains energy. And we'll talk about that a little bit more later on. Okay. So just as a reminder, when the electron moves away from the nucleus, this is what happens when it absorbs energy by burning oftentimes, or by being plugged in. Some lights do this. When you plug them in, electricity runs through them, and that's the energy source. So this is kind of our first step. You burn it, the electron jumps away from the nucleus by absorbing energy. Then we have our second step, is when the atom emits energy, which we see as light, when it falls back down to wherever it started. It shows it like it's moving into the nucleus. It doesn't go into the nucleus, it's just moving closer to the nucleus again. Okay. All right, so that's an overview of what electrons do in atoms when they are burned, and we will talk more about the different colors and what the colors tell us later on.